All right, let's talk about interest. Interest can be broken down into basically two categories. You have your simple interest and you have your compound interest. In this video, I'll talk about both. Inside compound, we'll make the distinction between two different formulas. This formula right here is if your compound interest is compounded continuously, and over here if it's compounded yearly or monthly, quarterly or daily. There's a specific time period that will be compounded, and I'll explain what compounded means in a little bit. But the interest that we're talking about here is, the basic example would be if you, put money into a savings account, and after a certain period of time, it's going to sort of gain money on that money, and the R in all of these is your interest rate, and that's given by a percent. That needs to be changed into a decimal for these problems, but the interest rate is basically going to tell you how much your money is going to sort of grow. The higher the number, the better. A lot of savings accounts have really small interest rates, and the higher your interest rate, if you open some sort of like mutual fund or money market account or something, your interest rate is going to be a little bit better than just a regular savings account. But we're not going to get into all that stuff like in terms of the finance side of it. We're just going to talk basics. So the R in all these is the rate, the interest rate, and remember to turn that into a decimal. The P is your principal. Principal is the amount that you started with, or the amount that you actually, deposited in your account to begin with. T is time, and time is always going to be given in years. So if it's not given in years, you have to sort of convert it to years. And in this case, the I, of course, is how much interest you are accruing. Over here in the compound world, the A is how much is in your account. So this is going to include interest plus principal. P is principal. E is, as you know, the base of the natural log. The base of the natural log. So that's roughly 2.718. R and T are rate and time, and same thing over here. The only thing that you'll see over here is this N value. And this N value is how many times the account is compounding. How many times it is compounding yearly. So if the account says it's compounding annually, that's just that N value would be 1. If it's compounding monthly, that N value is 12. If it's compounding daily, that N value is 365. If it says it's compounding quarterly, that means it's 4. Compounds 4 times a year. So these equations a lot of times are going to be provided for you on formula sheets. I know for my class you don't have to memorize them, which is a good thing because they all sort of look similar and stuff like that. But let's get into a few simples, and then we'll do some compounds, and then we'll wrap it up. So number 1, how much interest do you earn if you invest $4,500 at 9.5% for 6 years? This is a really good interest rate. Obviously, most interest rates for savings accounts are less than 1%. So this is a lot of money that you're going to be gaining here. But anyway, let's go through this one. We've got our P value, which is 4,500. Our R value, we're going to change that to a decimal, 0.095. This is our T value, that's 6. And this is just simple interest. So the interest is equal to PRT. The P is usually capitalized, so PRT. So I is equal to 4,500 times the rate times 6. So let's go to our calculators. So 4,500 times 0.095 times 6. So this account earns $2,565. $2,565. That's a lot. At the end of that, A would be the amount in your account, is the amount that you entered in, the amount that you initially deposited plus your interest. So it's going to be P plus I. So the amount in your account is $4,500 plus the interest that it accrued. So if you go and you add that to 4,500, you've got $7,065, which is really nice. All right, let's try these three. These are all simple. So this would be a good time to pause it, give these three a shot, see if you can get them, and I'll go through them in a second. So number 2, how much money do I need principal to get $18.20 at 3.25% in 8 months? So my interest formula, in this case, I'm going to have to probably solve it for P. I'm looking for P, so let's enter in the interest, which is $18.20. The rate is 0.0325, and the time is 8 months. Put that in terms of 12 months, 8 over 12. So let's get P by itself. So if you wanted to transform that equation first, you would say I over RT is equal to P. But from this point, I'm just simply going to take 18.2 divided by 0.0325 times 8 over 12. So let's go ahead and do that now. So 18.2 divided by 0.0325 times 8 over 12. And I get $840. So what that means is my initial account started with $840 in it. That's how much I deposited initially. And after 8 months, at 3.25%, I accrued this much interest. So my ending balance, my ending account balance is $840 plus $18.20. So that's $858.20. And that might not seem like a lot, but keeping in mind it was only 8 months, so it's pretty good. Number 3. Again, simple interest formula. This time I'm going to solve it for time. How many months will it take if I invest $5,000 at 5% to make this much interest? So let's get time by itself first. Interest is 136.48 over the principal, which is 5,000, times the rate, 0.05. So let's go ahead and multiply this out. I've got 136.48. Let's divide 5,000 times 0.05. Enter. So there's my time, right? My time is given in a decimal 0.546. So T is 0.546. Now that's always going to be given to you in terms of years. This question wants in terms of months. So let's just multiply that times 12. And we'll see that we get about 6.5 months. About 6.5 months for number 3. Number 4, how many years will it take for that principal, 745, to make this much interest at that much? So let's go ahead and I equals PRT. And this time again we're looking for time and years, so it should be a little easier. My principal, let me get T by itself. My principal in this case is 745. So P is 745. My rate is 0.08 and my interest is 178.8. So just plug it all in. 178.80 over 745 times 0.08. calculator time. 178.8 divided by 745.08 times 0.08. And I get 3 years. There you go, simple interest. Let's move on to compound. All right, here we go. We see this word compounded, so that means we're going to use a different formula than simple. And I know that annually, that means that my n value is 1. Remember, your n value is how many times per year it compounds. So up here in my formulas, I had 2 compound formulas. This one on my right, we're going to use this one when we don't see this word continuous. All right, continuously compounding means it compounds, you know, like every single sort of millisecond. It's always compounding. If I see a specific time, in this case I see annually, I'm going to use this one over here. So I'm using this formula. I'll copy and paste it down. And I'm using n equals 1 for my n value because it's compounding annually. So let's see here. Here we go. So in this case, A is the amount that is going to be in the account. So that's going to give us the answer right away. So let's say $6,000, 1 plus the rate, 0.08, over the n value, which is 1, times the n value, which is 1, times the year, the time, which is 10. So let's go ahead and put this into our calculator. So I have 6,000 times quantity, 1 plus 0.08 raised to the 10th power. So in my account, I'll have $12,953.55. So if you think about that, 10 years, your account has more than doubled. You have a really good interest rate. You put in a lot of money to begin with, and now you're sitting 10 years later with almost $13,000. That's really, really good. Number 6. Here we're compounding quarterly. That means 4 times per year. So A is equal to my principal, 1 plus R over N raised to the N times T power. So I have $4,000, 1 plus my rate, which is 0.064, over my N value, which is 4, raised to the 4 times 3. Go to my calculator, slide it over this way a little bit. So I've got 4,000, parentheses 1 plus another parentheses 0.064 divided by 4. Close my parentheses, raised to the 4 times 3 power. So 4839.32. 4839.32. So after 3 years, our account gained, $839. At this point, it's probably worth talking about, what it actually means for interest to compound. So if this thing is compounding basically 12 times, what we're starting at is $4,000, right? And the first time that we compound our interest, right, that principal is getting multiplied by 0.064. And that amount is going to give us the interest after the first time that it's compounded. So let's figure this out quickly. So 4,000 times 0.064. So the first time it compounds, it makes $256. Now, so this is within like the first, after 3 months. So let's say we put in our money on like January 1st. So this is like January, February, March. This is going to be like around, March or April or something like that. So now our account has $4,256 in it. The next time it compounds, it's going to, the 0.064 is going to apply to the new balance, not to the original principal. So when it compounds, the word compound means that the interest rate is being applied to the new account balance rather than the initial principal. So now when we enter that in, so 4256 times 0.064, it's $272.38. $272.38. Now that is going to be added to, this is going to be added to this number. And then the next compounding, which will be around like September, I guess, will be the sum, it'll be 0.064 times the sum of these two numbers. So that's what it means to compound. In simple interest, the interest is constantly being attached to the principal only. So if you think about it, right, it's to your advantage for your investment to be compounded as much as possible. If it can be compounded yearly, that's great. That's better than simple. But if you compound quarterly, that means you're compounding 4 times a year. Over a 3-year period, you're compounding 12 times. If you compound monthly, that's even better. That's 12 times a year. If you compound daily, that's even better. But the best one is to be compounded continuously. Continuously compounding stuff gets compounded, like every second, just constantly being compounded. And you're going to make the most money that way. Not going to be a huge difference between compounding like daily and compounding continuously, but you always want a continuously compounding event if you can get one. All right, so here we go. We have finally our compound interest. So here we have the amount that's in the account, principal times e to the RT. Let me make sure I got that right. Go back up to the top. Yep, PE to the RT. Where in this case, E is just a constant. Remember I said that that's roughly equal to like 2.718. It's the base of the natural log. Principal in this case is going to be 4,000. E raised to the 0.05. And it's being, we're asking the question after 3 years, so T is 3. So here we go. Let's take this, put it into our calculators and see what we get. Maybe we'll compare it to some other compounding. So 4,000 times E raised to the 0.05 times 3. So 4647.34. And we're talking dollars and cents. You always want to round it to that second spot. So if you're compounded continuously after 3 years at a 5% interest rate with a principal of $4,000, you've made $647 on your initial investment. So let's compare it to simple, first of all. Then we'll compare it to compounded it's quarterly, and then annually. So if this were simple, it'd be P times R times T. It's going to be 4,000 times the rate times the time period, which is 3. So simple interest only gained $600. Still a lot, but certainly not as much as compounding continuously. Remember, this is, over here is continuous. Let's compare it to quarterly. So now we have I is equal to P times 1 plus 0.05 over 4 raised to the 4 times 3. So let's put that in our calculators. P is 4,000 again. 1 plus 0.05 divided by 4, close, raised to the 12th. 4643 and 2 cents. So this one in red was 4,600 if you add them together. Annually, so let me do annually now. We have A is equal to our principal times 1 plus 0.05 over 1 raised to the 3 times 1. Let's go ahead and calculate this. 4,000 times 1.05 raised to the 3 power. 4630 and 50 cents. So you can see with our continuously compounded interest, $4,647 annually, about $17 less, simple about $47 less, and quarterly only about $4 less. All right, so the more you compound, the better. Continuous is going to gain you the most money. Now, if we were to compound this daily, the difference would be almost nothing, but I think you get the point. All right, so try these 3. See if you got the concept yet. So go ahead and give these a shot. See if you can get all 3 of them. See if you can figure out whether it's simple interest, compounded, and if so, if it's compounded, what kind of compounding are you dealing with? So go ahead and pause it right now and give these a shot, and I'll scroll down and give you the answers in a second. So here you go. Hopefully you got all 3 right. As you can see, 2 and 3 are the same problem. The only difference is number 3, you're compounding continuously, and number 2, you're compounding only once per year. So n is 1, and you can see that you're making, a little bit more money compounding continuously. So I hope you enjoyed this. A lot of information there, but I tried to make it. I tried to simplify the topic as much as I possibly could. So, any questions or comments, just shoot them in the comment section below. And thanks for watching.